Hey guys, welcome back. So in the last video we talked about three notations that are used to measure performance of a given algorithm, whereby we saw omega, big O and theta. I hope the theory part of all these three notations are clear to you. Now in this video let's try to understand these three notations with the help of a simple array example. So here we have a 1D array. As we can see that this array is not a sorted one. Now this dot dot over here implies that there are lot more numbers in between these arrays. It can be millions or billions of number. So let's say there are 1 million number here and another million number over here. So the size of this array is, let's say, around 2 million. Now our task is to find a given number in this array. Fine. Now let's say if we want to find number 10 is there in this array or not. So the algorithm is simple. All that we have to do is we have to start from the first cell. If the value of this cell is equal to the value that we are trying to find, then we are good. We simply return the cell number and we are done. Else we keep going towards right, visit each and every cell, and once we find out number 10 in that cell, we return the cell number. But in case if we reach till the end of the array and still we did not find number 10, then we simply return error message saying that number 10 does not exist in this array. So let's start our algorithm. So the task is we need to find if number 10 is there in this array or not. So we go to the first cell. Is this equals to 10? No. Fine. We go to the next cell. Is this equal to 10? No. We go to the next cell. Is this equal to 10? No. We keep going towards right until we reach this cell over here. Is this is equal to 10? Yes. So we return this cell number. Now how much time did it take for us to reach and find number 10? It took us n time. What is n? N is the size of the array. So let's say visiting each and every cell takes 1 unit of time. Now 1 unit can be anything. It can be 1 millisecond, 1 second or microsecond, whatever. So we are not concerned about the unit. We are just concerned about the number. So it takes 1 unit of time to visit first cell. Another 1 unit of time to visit second cell. Another 1 unit of time to visit third cell and so on. So in total we have n number of cells over here. So it will take n into 1, that is n unit of time. Now let's see how we can denote this n in terms of notations. Now let's say if we want to represent the time taken by our algorithm to search number 10 in this array in terms of omega. So what we'll say? We'll say it will take omega of 1. Why omega of 1? Because omega always guarantees that the running time of an algorithm will not be less than the given time. That is, minimum this much time will always be taken by the algorithm to search for a number. Now in this case we took n time. Now in the other case, let's say if we want to find number 26, that will take 5 units of time. Or if we try to find number 3, it might take 3 units of time. But it will never be less than 1 unit of time. And what is that 1 unit of time case? That is when we try to find number 5. Fine. So I hope you have understood why we have put over here as omega of 1 and not omega of n. Now let's see how we can represent our algorithm in terms of big O. So if you remember, big O always guarantees that the time taken by the algorithm will not be more than the given time. So in case we are trying to find number 10, this will take n time. Similarly, let's say if we want to find number 54, so this will take 4 units of time. Finding number 26 will take 5 units of time. So we see that in the worst case, it will never exceed n units of time, in which case we come to the last cell and return its value if the value matches. Else we simply say that the value does not exist in the array. Now the third notation was the theta notation. So if you remember, we said that theta notation basically gives us the average time complexity. So let's say sometime we want to find out value 54, it might take 4 units of time. Sometime we might to find number 55, it might take, let's say, 1 million units of time. At other times, let's say we want to find number 10, this might take 2 million units of time. And then sometime we might find number 5 or 18, which might take 1 or 2 units of time. So you see that depending on what kind of a data that we are trying to retrieve from this array, our performance changes. Sometime it takes 1 unit of time, other time it might take 1 or even 2 million units of time. So when we do an average on a huge set of data, the runtime comes to n divided by 2, which is denoted by theta. Now one important thing to note here is that for academic purpose, we need to know all these 3 types of notations. But when it comes to interviews, we are mostly concerned only about big O notations. We rarely even go for omega or theta. Hence, going forward, we will mostly be concerned only about big O notations. Fine. So with that, we come to end of this video. In the next video, let's see some of the examples of runtime complexities. Thanks for your time. See you in the next video.